Alright, so the next set of standards all really blend well together, so I'm going to create for you this video that kind of walks you through how to do all of them. So 7.RP.2, I can determine if two quantities are proportional using a variety of methods: tables, graphs, diagrams, equations, or verbal descriptions. So I'm going to first break down to you what it looks like in a table, a graph, and an equation, and then we're going to practice some together. Alright, so proportional relationships. So remember from last video what a ratio is, because you're definitely going to need that knowledge to go forward with these new set of standards. So a proportional relationships are relationships that have the same ratio. So when we're working with our equations, y equals kx is the typical way we're going to use equations now. Our x and our y, those are variables. Those are part of our graphs. That will all make a lot more sense as we start practicing. What I want you to focus on is the k, because your k is representing your constant of proportionality. So your k means that for every way your x value increases or decreases by something, your y value will also have that same increase or decrease. So to figure out k, you can always divide your y by your x. And when we're working with tables, that is so important, because that helps us tremendously to determine what that constant of proportionality is. So if you look at that table, we have some x values, we have some y values, and to determine the constant of proportionality, we're going to set up some fractions, just like in this portion here. So y over x. You do that for each row of your table. Do not leave any row undone. Y over x, y over x, and y x. Oops. By x in this one I actually mean 10, not just x. So forgive me. Alright, so we have a bunch of fractions now. We have a bunch of ratios. Let's see if they are if they equate to the same value. So 3 divided by 1 is 3. 12 divided by 4, 21 divided by 7, and 30 divided by 10. Now because all of these are the same, we now know for sure that our table represents some proportional relationships. So if we were to set this back up into equation form, we would take our constant of proportionality, which is 3, and it's done. When we're working with our graphs, in order to determine if we have a proportional relationship, our graph must pass through the origin. Remember, the origin is the place where your x and your y-axis intersect, and our line definitely goes through that on this example. So we'll do some more practice with that to help you make sense of it, but it shouldn't be too bad. So, to determine if tables are proportional, you are working with every single row on that table. Set it up. Y over x over negative 4, negative 6 over negative 3, negative 7 over negative 2, and negative 8 over negative 1. All of those have to equate to the same value. So I'm looking at those, and some of those fractions are ugly. Don't worry about it. You do not necessarily have to do all of those, and I'll explain why shortly. Start with what you know. Teachers do it, students should do it too. So negative 8 divided by negative 1, I know for a fact that that equals 8. Okay, so forget about it. It's done. This negative 6 divided by negative 3, I can do that easily too. I know that equals 2. Wait. Already I have numbers that are not the same. That means this entire table is not proportional. I don't have to do any more work. So those icky fractions in this problem, I don't even have to worry about, because case closed. For number 2, I'm going to set it up the same way. Y over x, y over x, y over x and y over x. Start with what you know. I know this one here will be the easiest for me to work with. 0 divided by 8, that's just 0. All day, every day. I'm looking at those other ratios. I know they don't equal 0. I can tell just by looking at them, because they all actually have parts to their whole. See, another way of thinking about 0/8 is that it's 0 parts out of 8. So any ratio that has parts involved, even if they're negative parts, they still have parts, which is more than what I had. Therefore, they do not have value. This one is also not proportional. Final table, set it up all the same. Y over x, y over x, y over x, and y over x. For each of those ratios, I need to break them down to a more equivalent fraction of a smaller, using smaller numbers. So to simplify, I know I can divide this one by -10 because both of those numbers are multiples of -10. I'm dividing this one by -8 and this one by -2. And I can divide this one also, just to make it prettier, so I don't have any negative numbers. I see I have the same constant of proportionality in 1/7, so this one is proportional. Okay, let's keep it moving. Constant of proportionality. So because this specific exercise is asking us to find the constant of proportionality, we know these tables represent proportional relationships. So all of the ratios, when we're comparing our y to our x, equal the same thing. So for this one, I want you to just divide. That's all you have to do. Don't complicate matters any for you. So if I'm working with this first one, this first example, I can pick any y value I want. Just be sure whichever y value you pick, you also pick the corresponding x value. So y over x, 30 divided by 3, 10. That's where they got this 10. I can do the same for the second table here. I can pick any of these. If I do 27 divided by 9, that equals 3. So when I set it up in my equation, the y and the x part stays the same. That k is the part that I change once I figure out what number it is. I do the same down here. I can pick any of these. I'm going to have 114 divided by 3. Please do not shy away from these problems that have larger numbers to work with. Don't shy away from ones that have fractions. Don't shy away from the negative numbers, because you're going to see it all. And I want you to note which ones are more difficult for you to solve. I'm not expecting you to be master mathematician right now. What I am expecting is that you will recognize when you struggle and where you struggle, so that we together as a team can get you where you need to be. So this one involves a little bit more work, but it doesn't mean you won't do it or you can't do it. So set up your division and get it solved. You can use short division, you can use long division. It does not matter to me. Whatever process works for you, that's what I want you to use. So I'm going to do short in the interest of time. So that equals 38. So when I set it up in my equation, y stays the same, my k is the one that's different. Alright, so on this page, there is a multitude of things that we can practice, and I think this will be good to kind of see them all, kind of interact with each other, whether we're using the verbal description, a table, or a graph. This kind of brings it all together for us. So let's do one. Joe can do 10 multiplication problems in 5 seconds. A. At this rate, how long should it take Joe to do 2 multiplication problems? So we can hold off on that question because it's going to become very clear after we finish our table, and maybe even after we finish the graph. So using that information, Joe can do 10 multiplication problems in 5 seconds. So in 5 seconds, we can go ahead and put that 10. Now we have a row in our table that we can use to work with to determine our constant proportionality. So remember that constant proportionality is K equals Y over X. So in this, if we divide Y over X, that's going to give us 2. So that means that to go from 5 seconds to the amount of multiplication problems Joe can do, we multiply by 2. We can do the same on this row. We can do the same on this row. We can do the same on this one, and keep going until we are finished with our table. Boom. So if we read that question again, at this rate, how long should it take Joe to do 2 multiplication problems? So make sure you're looking at this correct thing. So 2 problems takes Joe 1 second. Now let's put this graph together. So our X value is our number of seconds. The Y value is the number of problems. Sorry, I wrote kind of upside down in reverse. Make sure you number your axes. So I'm just going to count by ones because these numbers are small enough to do that. Where is our origin when we're working with a graph that looks like this? Our origin is always our bottom left corner if we're working with just one quadrant, as long as it's the first quadrant. So in order to graph, we just plot points. So our first point is at 0, 0, which I accidentally already did. Cool. Then we have 1 second. So in 1 second's time, Joe can do 2 problems. So we find 1 on our X, and we go up till we get to 2 on our Y, and we make a point where those 2 values intersect. We do the same thing. We go 2, 4, 3, 6, 4, 8, 5, 10. And once we have all of those, we just connect those dots. And I don't have a ruler, I'm freehanding it, so don't judge me. Thank you. Bingo. So, what do we know? We know this is a proportional table because our constant of proportionality is the same. Is our graph proportional? Yes, because it goes through the origin. So our last question is, what is the unit rate? Your unit rate is found where your X equals 1. So you go on your X-axis, you find 1, you go up to your Y value, there you go. So we can do 2 problems per second. Per 1 second. And which that was what that question A was asking us. Question A was disguising itself in a way to ask us for the unit rate without coming out and just say, what is the unit rate? So that's pretty good. Joe's pretty good. If he can do 2 multiplication problems per second, I like to think as your local math guru, I could probably do more than that. We'll have to test that. Maybe I'll come up with some game where we can all test how fast we can do multiplication problems. But for now, we're going to wrap this up. So we went over quite a few standards in one video. You may have to watch this multiple times to get it. We'll do some practice, so don't stress. I know it was a lot. I probably went over it kind of fast, but this is the meat and potatoes of it. So get used to working with the constant of proportionality, unit rates, ratios, division is key here. It's a lot of review things, but there's also some new things. So, ciao for now.